Hey guys, I hope you're doing well. So this is the first video of this unit. We'll be talking about trigonometric functions. We've looked at polynomial functions, rational functions, and now we'll start looking at trigonometric functions, and we'll start with a review of angles. So an angle is said to be in its standard position if the vertex is located at the origin. I hope you can see that this is the vertex of the angle, or like the edge of the angle. If it's at the origin and its initial side is extending along the x-axis, right? This is the initial side. It's going along the x-axis. If an angle is in that situation or that case, then it's said to be in its standard position. Standard position because that is the standard position of an angle. Alright, we measure angles if they are measured going upwards, or if they are measured anti-clockwise, then they are positive angles, and if they are measured clockwise, then they are referred to as negative angles. So clockwise is negative, anti-clockwise is positive. This is still the initial side because it's along the x-axis, and the terminal side is where the angle terminates or ends, so that's why it's called the terminal side. This angle is measured clockwise, so that means it's going to be a negative angle, right? Negative angle, this just means negative. This one, on the other hand, is measured clockwise. As you can see, the arrow or the spiral goes clockwise, so that is a positive angle. Some Greek letters that we're going to use to refer to angles are theta, phi, alpha, beta, and gamma. You will see this a lot, especially this theta and this alpha. You see them a lot, and then followed by this in terms of being popular or common, and then this. And these are more popular in physics and I think chemistry, but these are the ones we'll be seeing a lot. They're just used to mean an angle. If I want to draw a 45-degree angle, then I'll just start here and then draw a 45-degree angle. This will be its terminal side, this will be its initial side. I'll measure it clockwise because it's, anti-clockwise because it's positive. And yeah. So that's how you draw a 45-degree angle. A negative 110-degree angle, I'll start here. I know negative has to be clockwise, right? What did I say here? Yeah, I said anti-clockwise because it's positive. I hope that's what I said. Here it has to be clockwise because it's negative. I know if I go this way, that will be 90 degrees. And if I go another 90, that will be 180 degrees. So 110 has to be between negative 90 and negative 180. And to be more precise, I think it's closer. I think it's closer to negative 90 than it is to negative 180. So you'll draw 110 degrees, negative 110 degrees, like this. Still, this is the initial side of the angle, and that is the terminal side. Alright, when we're talking about angles, and I'm sure you've seen this before in your earlier classes, there's something called quadrants, and that's simply the quarter of a circle in which the angle lies. If you break down a circle, if you think of this as one big circle, it can be broken down into 4 quarters, and this is 1 quarter, 2nd quarter, 3rd and 4th, and they're called quadrants. So yeah, angles are found in quadrants. So yeah, quadrant 1, quadrant 2, 3, and 4. Quadrantal angles are angles like this that have their initial side and terminal side on the axis, right? So if its initial side is along the x-axis and its terminal side is along the y-axis, or it could be this way, or it has to be that and that, or that and that, then it's a quadrantal angle. So it has to be a 90-degree angle. Radians. A radian is the central measure of an angle. Is the measure of a central angle of a circle that intercepts an arc equal in length to the radius of the circle. Well, that is an interesting definition. I don't know if it makes sense just by looking at it, but I'm just going to simplify it by saying that a radian is simply the ratio between the circumference of the circle and the radius of the circle. It's the ratio between the distance subtended by an angle. So this angle here, right? This angle here subtends, this angle theta subtends an arc of radius r, right? So the ratio between that radius of that arc and the radius of the circle is what is known as a radian. So you'll find that if this arc has a radius r, then my radian will be theta, which is r divided by r. Commonly, this arc is known as s, and therefore the radian will simply be s over r. This ratio is going to be the same, this ratio is going to be consistent throughout the circle. So here when it says it's a measure of a central angle of a circle that intercepts an arc equal in length to the radius, if that arc at the edge of the circle is equal to the radius of the circle, I hope you see that that ratio will be equal to 1. That angle which is responsible for getting a ratio of 1 is what is known as a radian. Let me repeat that. The angle here that makes an arc such that the ratio of that arc and the radius, so therefore that arc divided by radius, when that ratio is equal to 1, the angle responsible for that is called a radian. So yeah, that's simply what a radian is. If you want to know more about how these radians came to be, you can ask the physics students. So since we know that the idea is that I'm getting the circumference of a circle and I'm dividing it by the radius, then if I look at the entire circle, the circumference of the circle is 2 pi r divided by the radius, and I'll end up with theta is equal to 2 pi. So this is why this 2 pi is representing 1 revolution, and we know 1 revolution is the same as 360 degrees. This is why 360 degrees is represented by 2 pi radians. This is something obviously you studied, that's why it sounds like I'm rushing over it. But if you need some more explanation on this, you can find me and I'll help you. Since 360 degrees is 2 pi radians, then therefore if you divide by 2 both sides, you'll end up saying that 180 degrees is equal to pi radians. So if I want to convert degrees to radians, I know that 180 degrees is equal to pi radians. Therefore 1 degree, if I divide both sides by 180, 1 degree will be equal to pi divided by 180 radians. So if I want to get any number of degrees and I want to change it to radians, I will simply divide it by 180 and multiply it by pi. Or in other words, you can say I will multiply it by pi over 180. Same thing. So I'll reduce this. 0 goes with 0. By 6 I'll have 2. By 6 I'll have 3. Then I end up with 2 pi divided by 3 radians. If I want to change radians to degrees, remember 180 degrees is equal to pi radians. That means that 1 radian is equal to 180 divided by pi degrees, right? So if I want to go from radians to degrees, now I have 5 pi over 6 radians, and I want to go to degrees. I hope you can see that I'll just get my radian value and multiply it by 180 divided by pi. So if I want to change this to degrees, let me just do it in this direction because it's more natural. I'll have 5 pi over 6 times 180 divided by pi. Reduce that and then you can find the answer. Coterminal angles are angles, two angles in their standard position that end at the same side or end at the same line or have the same terminal side. Terminal just means end. So this angle 140 degrees ends here, it starts at the same axis, and at the same time the angle negative 220 starts still here on the x-axis but ends there. So those two angles are called coterminal angles. Example, find the angle between 0 and 360 that is coterminal to the given angle. So the given angle is negative 40. Let's just see where negative 40 is. It's over there. So the two coterminal angles, right? Because if negative 40 is measured this way, that's negative 40 degrees. I want to find two angles between 0 and 360 degrees. No, sorry, one angle between 0 and 360 degrees that's coterminal. I'm just going to go the other way. So I'll go this way and find that that angle will be positive. If this is 40 and I know if I start here, this will be 0, this is 90, this is 180, 270, and again if I keep going, this will be 360. So if I want to know what this angle is, I can just take 360 and subtract 40, and that angle will be 320 degrees. Positive 320 degrees because I went clockwise. 700 degrees. So yeah, this one is a bit tricky. Ask yourself, 700 degrees, how many times do I, because when I start here at 0, I'll come back and it will be 360 degrees, the first revolution. And if I come back another revolution, it will be 720 degrees, right? Because it's 360 times 2. So 720 degrees, if that has to be 720 degrees, then surely 700 degrees has to be somewhere here, right? And that's after going 2 revolutions. You go once and then you go back again. That will be 700 degrees. So if I want to find the other angle between 0 and 360, notice that these are both positive. So I can't just say, oh, negative, this angle is going to be coterminal. Negative, this would be negative 20 degrees. That won't be the answer because this is between positive 0 and positive 360. I need to find the other coterminal angle, which happens when you go just once, right? So when I go just once, it's the same thing as subtracting 20 from 360 degrees, which is 340 degrees. So the other coterminal angle for 700 is 340 degrees. Find the angle between 0 and 2 pi that's coterminal to the given angle. Now, one of the tricks to use here is figure out what is this angle close to, and in order to do that, you're going to need to know your radians pretty well. Obviously, you're going to get practice from your homework, which will help, but we know this is 0. This is supposed to be 90, but in radians, that is the same thing as pi over 2. This is supposed to be 180, but in radians, the same thing as pi. And this is supposed to be 270, which in radians is the same thing as 3 pi over 2. And this is supposed to be 360, which in radians is the same thing as 2 pi. I hope you can see that I'm just adding half of a pi. This is half a pi. This is another half, so to make a full pi. This is another half, so I make 3 halves. And then this is another half to make 4 halves. So I'm just adding pi. If this is difficult, first change this to degrees, find its coterminal angle, and then convert back to radians. However, if this is negative pi out of 9, in your mind you know that 180 divided by 9 is 10 degrees, right? And if it's negative, then that has to be somewhere here. But even if I didn't change that to degrees, negative pi out of 9, obviously I know it's going to be a negative angle. I mean, it's going to go down this way because it's a negative angle, so I have to go clockwise. And since it's pi out of 9, and if I had gone this way in negatives, this would be negative pi out of 2. So that already shows you that it's in this quadrant. Now, since it's in this quadrant, you're looking for the other angle, the coterminal angle, that is between 0 and 2 pi. So that means I'm going to go this way, right? So I'm trying to figure out for this angle, what is this angle minus this angle, right? So I'll look for 2 pi minus this angle, which is pi over 9. 2 pi minus pi over 9. 2 pi is the same as 18 pi over 9. And I'm subtracting pi over 9, which will give me 17 pi over 9. So that's my coterminal angle. But like I said, you can change it to degrees, find the coterminal angle, then come back to radians. Now let's look at this one. 13 pi over 6 is the same thing as 2 whole numbers, right? 1 over 6 pi. So this is the same thing as 2 pi's plus pi over 6, right? You go 2 whole pi's and then another pi over 6. It's the same exact thing. So I'm going to draw this here, and then I say, I know this is 0, this is pi over 2. Remember, just keep adding halves. This is pi, this is 3 halves, and this is 2 pi's, right? So this angle is 2 pi's plus another pi over 6. So I already have my 2 pi's. I just need to add pi over 6, and I know that will be in this quadrant because it's not as big as pi over 2. Again, if this is confusing, change to degrees, then change back and work like that. So this is pi over 6. I need to find its coterminal angle. I can and that angle has to be between 0 and 2 pi. So what are my options? If I go like this, I don't get that angle, right? Because that will already be pi over 6. Oh, sorry. The angle that has been given was got by first going around a whole 2 pi, and then coming back to this. So its coterminal angle is simply going to be, if you just go there, and you don't have to go through the whole, the whole revolution. So that one is simply pi over 6. I hope we can all see that. If we can't, ask questions or change to degrees and then work like that. So in each quadrant we have something called a reference angle, and the reference angle is the smallest acute angle, which you can call T prime, which is formed by the terminal side of the angle T and the horizontal axis. So if this is my angle T, this is the angle T that's forming, this is its x-axis and this is its terminal side. I can use this angle T as a reference in each of the other quadrants, right? In the second quadrant, which is over here, if I find an acute angle that has the same value as this small t, and starting from the x-axis, so that angle will be starting from the x-axis here and then going to the terminal side, right? That is going to be my reference angle for that quadrant. If I go to the third quadrant, again remember that reference angle has to be starting with the x-axis, right? Has to be starting with the x-axis and the terminal side of your initial angle. That's going to be your reference angle. And in this fourth quadrant, my reference angle will still have to start at the x-axis and then be with the terminal side of the initial angle t, which I started with, and that's going to be your reference angle. Let me show you an example. An example is if you have an angle 30 degrees here, right, in the first quadrant. If you go to the second quadrant, you're trying to ask yourself what acute angle, right, what acute angle is going to have the same terminal side as this big angle. So here I started with 30 degrees. Here, this whole big angle, let's say it's wait, that's not the second quadrant. Second quadrant is over here, right? So this is my angle T, and the reference angle that I want to use, if this angle T is 150 degrees, the reference angle I want to use is this angle here that starts on the x-axis still and has the same terminal side as my big angle T. So that angle will be 30 degrees and it's an acute angle. If I go to the third quadrant, and this is my angle, let's say that angle is 210 degrees, right? My reference angle has to be the angle that starts with the x-axis and has the same terminal side. So in order to figure out that angle, I know this is 180 and this is 210. I hope you can see that that's still 30 degrees. Here this was 180 and that was 150. If you subtract them, you still get 30 degrees. And finally, in the fourth quadrant, if this angle here is 330 degrees, right, the reference angle will be the angle that starts at the x-axis and has the same terminal side. And since this is 360 and that's 330, that reference angle still has to be 30 degrees. So I hope you can see that we've maintained the same 30 degree as our reference angle in each of the quadrants. Arc length, again going back to the definition of a radian, remember the radian is the angle that, the angle such that the ratio of the circumference and the radius was 1. This was the definition of a radian. Let me remove that delta symbol. Delta, go away. Okay, so it's just radian equals s over r. If I multiply by r both sides, you can see that that distance at the circumference is equal to r times theta. So that's where we get this formula from for arc length. Arc length is equal to r theta, where the theta is the angle in radians, measured in radians, and the r is the radius and s is the arc length. So one example is here. If I want to find the length of an arc of a circle, the radius is 12 inches and the central angle is pi over 4. So the length of the arc will just be 12 inches times pi over 4, which will be equal to 3 pi inches. And yeah, so this is your homework. I hope you can, we'll go over it tomorrow. Bye.